So let's talk about mirrors and image formation. Now, before I get too much into this, I really want to talk about what it means to be an image. All right? So what happens is we take an object and we put it in front of a mirror. The light that reflects off of that object then goes and reflects off of the mirror. And then the important thing is what happens to the light after it reflects off the mirror. All right, the idea is that sometimes this light will reflect off the mirror and then come back together again. So that means that it's going to reform that same image. It's going to look just like it did when it reflected off of the object. And so that's what we mean by an image. It looks like an object. Now, if light actually goes through the image so that it reflects off and it comes back through and reconvenes, then we call that image real. Okay? That image is real. If, on the other hand, it just looks like there's an image, and in fact the light never reconvened at all, then that image will be called virtual. Okay? We'll find that if you use only a single mirror or a single lens, then real images are always inverted. That means they're always upside down. So you're looking through the lens, the object is right side up, the image is upside down. All right? Virtual images, on the other hand, will always be erect or right side up, okay? If there's a single mirror or a single lens. And then, of course, we can have magnification. The magnification is always given by the ratio of how far the image is from the mirror divided by how far the object is from the mirror. All right? So let's just do this real quickly with the simplest case, that of a plane mirror. All right, a plane mirror goes like this. You've got light coming from the object, and it just reflects straight back. So there's one of them. Let's draw another one. Well, I've got light from the object, and then it just reflects, and remember, angle of reflection equals angle of incidence. So it's going to go like that. Now here's the question. Are these two rays ever going to recombine? Well, it certainly doesn't look like it, right? They're just getting further and further apart. So what would I mean by an image? I mean, I stand in front of a plane mirror, I see an image. Here's the idea. When I stand in front of a plane mirror, I see these two light rays. But my brain doesn't automatically think about the mirror being there. It just says, okay, there's two light rays. So it extrapolates the light rays back as if the mirror wasn't there. And so look what it looks like. It looks like the light came from here. Look at that. Same distance behind the mirror as the object was in front of the mirror. Same size as the object. That's the image. Notice that the image is erect. It's right side up, and it's the same size and same distance away. So we have a virtual image because the light never actually was here. If I go and look behind the mirror, I'm not going to see anything there, right? Well, I'll see a wall, okay? So the idea is no light actually came here. It's a virtual, erect image. Same distance away from the mirror as the object with a magnification of 1. All right, which means it's not magnified. All right, so let's look at slightly more complicated cases. And these are the cases associated with curved mirrors. Now, we need to do this kind of carefully. There's 3 major cases. The concave mirror, 2 cases of that, and the convex mirror, only 1 case there, so that'll be nice. All right, let's look at the concave mirror first. All right, if the object is far away from the mirror, how far depends on how concave it is, how curved in it is. But if the object is far, let's draw a couple of these rays. Let's draw one to the vertex. All right, it's going to reflect off, same angle it came in at. All right, and then we'll do one straight out. So we'll do one just like this, and it reflects at the same angle it came in at. But remember, that angle is measured off of the normal. So I got to draw me a little normal all right? And then I got to draw the reflector. And look at that. We do have these rays recombining. So this gives us a real image, but notice that the real image, is inverted, okay? So this is going to give me real inverted image, all right? It's going to be closer. The magnification will be less than 1, all right? And so this is what happens. Now, let's think about what will happen if I start moving this object. It turns out what happens is, as the object moves closer and closer and closer to the mirror, the image moves further and further and further away, all right? These two things will coincide at a distance that's equal to the radius of the circle that this would make if you made it a circle. It's called the radius of curvature. How curvy is it? All right, the more flat it is, the bigger that radius is. The more curvy it is, the smaller that radius is. So these two things will come, they'll overlap, and then they'll go like this. And the image will go off to infinity as the object goes to a certain place in front of the mirror called the focal length. All right, and that'll be discussed in more detail in the segment on the lens equation. All right, so what happens if I get closer than the focal length? Well, let's see. Again, we'll draw two rays. There's one, and then let's draw another one. Draw this one in green. So we'll go straight over, and then remember, I got to give myself my normal. All right? And these two are actually not going to overlap. They're not going to ever recombine. All right? So I have to continue them backwards to see where my image is. And my image is now over here, much taller and virtual and erect. So this one's virtual, erect. So basically the idea is with a concave mirror, the object moves in closer to the mirror. I have a real inverted image that moves out away from the mirror. The two things coincide briefly and are the same size, but one of them's real. Well, the object is obviously real. The image will be real and inverted. And then the image goes out, keeps on going out to infinity. Once the object reaches this certain point, we go over here. And the image appears on the other side. It's now virtual and erect. And as the object gets closer to the mirror, the image will also get closer to the mirror. All right? So that's concave. That's the most complicated case. All right? Now let's do an easier case. Let's do convex. All right. Convex goes like this, in like that, and then again, I need my little normal out like that. All right? So there's one. Let's do another one. Here we go. Down like that. Notice that these two are obviously never going to recombine, all right? So that means that we've got a virtual image. We can determine where that is by continuing these geometric lines, and look what we end up with. We end up with the rest of what was going on here. So the issue is that here we always have an erect virtual image that's further away from the mirror than the object. In the convex case, we always have an erect virtual image that's closer to the mirror than the object. These mirrors are very, very, very useful in stores, for example, because everything has a smaller magnification than 1. And that means that if you use one of these convex mirrors, you can see more. You can see more going on. You can see the whole store at once, right? Which is not the case with these concave mirrors. Concave mirrors are actually used to magnify things. All right? So those are some qualitative ideas about the way that mirrors and image formation works.